question number 12 now, children, where they've given you these two complex numbers z1, z2, and they are asking you to find real part of z1 into z2 upon z1 bar. So we'll do it stepwise. First, let's find the product of these two complex numbers given to you here. Okay, so we know it, real part into real part, 2 into minus 2 minus 4, imaginary part into imaginary part. So minus 1 into plus 1 and minus of आता है, तो minus minus 2 negatives will make it positive and 1. Okay, and for imaginary part it's like imaginary into real, so plus 2 from here and imaginary into this real, another plus 2. So we end up getting minus 3 plus 4i. Okay, then conjugate of z1, 2 minus I becomes 2 plus I. Now let's form this expression which we had to evaluate. For that, first we'll form that complex number. So this was our z1 into z2 form. This was our z1 bar. Now obviously we'll multiply by conjugate of what we have in denominator. So it's real part square plus imaginary part square, 2 square plus 1 square, so that comes out to be 5. And multiplying again, I've already revised multiplication for you, so do that. Real part into real and minus imaginary part into imaginary plus I times real into imaginary, imaginary into real. Okay, so this expression is coming as, or this complex number is reducing to minus 2 upon 5 if you separate the denominator, and plus 11 upon 5 times I. Question kya tha? Real part of this complex number. So from here now we can easily trace the real part is minus 2 by 5. Imaginary पूछता तो 11 upon 5 बोलते, right? Okay, now for the second part of the same, they were also asking us to find z1 into z1 bars imaginary part. So first we will form z1 into z2 bar. That was our z1, this was its conjugate. Multiply again. So this is ending up giving you only real part. Okay, because यहाँ से आएगा minus 2i, यहाँ से आएगा plus 2i, तो imaginary part आपका cancel हो गया. Or the other way round, we know this, that any complex number into its conjugate gives you its modulus, and modulus is real number only. Imaginary part, real part square plus imaginary part square. Okay, और multiply भी करोगे तो you'll see your imaginary part is vanishing, right? अब आपका expression in question was 1 upon this, so that becomes 1 upon 5. Whatever, we end up getting a purely real complex number जिसमें imaginary part 0 होता है, we say that complex number is purely real. So if we are looking for imaginary part of this, that is obviously 0. Real part कहता तो 1 upon 5. Okay. Now in the 13th one, children, they are asking you to once again find modulus and argument of this complex number. Earlier we've done finding the polar form. So polar form में भी हमने यही किया था. Given complex number को we bring it in its standard form, a plus ib form, and then we find its r, modulus, and its argument. Okay. So same thing out here. So it's kind of a revision for you. So you will solve that on your own. I will take up this 14th one. Find the real values of x and y when product of these two complex number is coming out to be conjugate of this. Although all the questions out here are simple, let's take few examples. Okay, children, so that's your 14th one. So we are simply finding this product first. Again, real part into real minus imaginary part into imaginary. That is giving me the real part. And for imaginary, 3 into minus y, 5 into x. Okay, and this is conjugate. तो conjugate में आप imaginary part का sign change कर देते हो. Conjugate of this will become minus 6 plus 24i. Okay, then simply you have to compare the real part out here will be equal to the real part here. Imaginary part here will be equal to the imaginary part here. So you get two equations in two variables. So solving two equations simultaneously. I've done it by elimination method. You can choose your own method. So multiplying the first equation by 3, second by 5. Because ये y के हम eliminate करना चाहेंगे. So that becomes this 9, 15, and from here again 5 5s are 25, 3s are 15. So this is getting cancelled, and here the first equation we had multiplied by 3, so minus 18, this by 5. So we are ending up getting value of x as 3. Put that in any one of the equation and evaluate your y as well. Okay, the 15th one, now they are asking us to find modulus of this complex number. So naturally we simplify this, and the trick for that is we multiply by what we have in, by conjugate of what we have in denominator. And coincidentally in this question the two expressions here are conjugate of each other, so straight away we can take LCM. LCM लेने में से conjugate भी मिल जाएगा and दोनों merge भी हो जाएंगे. So taking LCM, denominator complex number into its conjugate, which will end up giving you real part square plus imaginary part square. So denominator simplifies to 2, and here when you're taking LCM, this becomes 1 plus i's whole square. This becomes 1 minus i's whole square. So opening it by a plus b, a minus b whole square here. A square plus b square plus 2ab, a square plus b square minus 2ab. There was this minus sign, be careful about it, put it in bracket, okay? And then simplifying, I square is minus 1, तो ये balance हो जाएगा, only 2i will remain here. Likewise here also आपका plus 1 minus 1 cancel, okay? Minus 2, and they had a minus sign in front, so plus 2i will remain, so that adds up to give you 4i, which was upon 2, so that becomes only 2i. So your complex numbers modulus, so modulus of this, इसका simplified form आया है 2i, तो 2i का modulus is under root of, it has only imaginary part, real part is 0, so under root of 2 square, which is 2. Okay, now for the 16th one, again this was given to you. Okay, cube of this complex number is this, then you have to prove this expression. So simply open this by a plus b whole cube, a cube plus b cube plus 3a square b plus 3ab square, and equating that to u plus iv as given. Okay, so x cube, I cube remember used to be minus of I, right? And then this I obviously remains, and here your I square, you would get I square y square whole square है, I square बन जाएगा minus 1. Okay, so simple questions हैं. Now grouping all your real part together. तो real part में क्या आ रहा है, यहाँ से x cube and यहाँ से आ रहा है minus 3xy square, which will be equal to u of course, क्योंकि यहाँ real part u है. Imaginary i's किस किस में थे आपके, 3x square y and minus y cube. That will be your v. Okay, now back to the expression that you had to evaluate. Put these values of u and v. And देखो इनमें x कॉमन आ रहा था, इसमें y कॉमन आ रहा था, so we've done that because we had x and y in denominator, which cancels out from the remaining x square and 3x square. Hence easily you are getting your proof. Okay, then now children, 17th one, they've given you modulus of one complex number beta as 1, and these are two complex numbers where this expression its modulus was to be evaluated. So there are two ways of doing these questions. We've done earlier where as a questions the, so we had assumed the complex numbers. Let the first complex number be a plus ib and beta be c plus id. फिर ये expression पूरा आप evaluate करो, इसको a plus ib form में लाओ, फिर उसका modulus निकालो. That becomes bit too lengthy, and we've studied properties of modulus as well as conjugate of any complex number. So I have done this by applying those properties. Okay, so let me see that we remember this property, that modulus square of any complex number is complex number into its conjugate. So that property we are trying to utilize here to simplify this, because we were supposed to find the modulus of this expression. So I have started by squaring this, considering the square because of I knew this property. So the complex number given into its bar लगा दो, conjugate. अभी conjugate की हमने क्या properties पढ़ी हैं कि this conjugate sign z1 upon z2 bar is z1 bar upon z2 bar. वो सारी properties पढ़ी थी, so we are making use of it. So this will be bar of what you have in numerator upon bar of what you have in denominator. Okay, further we also know that when you have z1 plus z2 bar, that is equivalent to z1 bar plus z2 bar. तो वो bar सब में multiplication में, quotient में, plus में, minus में, सब में carry हो जाता है. So it was whole bar, so it will become beta bar minus alpha bar as well. Likewise in denominator, ones bar minus alpha bar, beta bars bar. Okay, next step ये तो copy होता जाएगा आपका, and इसमें अभी this cannot be simplified any further, but here 1 bar, if it is a real number तो उसका कोई conjugate नहीं होता है, so 1 bar is 1 only. Here again अब ये product है तो इसमें भी carry हो जाएगा bar इसमें as well as in this, so it will be alpha bar bar, and bar of a bar becomes the number itself. Any number conjugate of conjugate is the number itself, complex number. Okay, so alpha bar bar, double bar will give you alpha, and then this will become beta bar. Okay, now simply multiply this into this and this into this. So when you're multiplying, this is beta into beta bar minus alpha into beta bar minus minus plus alpha into alpha bar, and beta into alpha bar. Likewise, denominator may be 1 into 1, this into this, multiplying. This is what you will end up getting. Okay, now back to the property we started with. Any complex number into its conjugate is its modulus square. So we can write in the next step this as beta, modulus of beta square. Okay, rest will be copied as it is, and here again this will be written as modulus of alpha square. Denominator, this will become modulus of alpha square, modulus of beta square, rest will be copied. Now you were given modulus of beta is 1. Next step में उसे replace कर दो. तो modulus of beta was 1. Wherever we had modulus of beta, that will become 1. So what is left over is coming exactly same in numerator and denominator. So its value is coming out to be 1. Okay. Now in the 18th one, it's saying find the number of non-zero integral solutions of this equation. Okay. So we'll simplify that. It was modulus of this complex number to the power of x. So modulus of any complex number is under root its real part square plus imaginary part square. Okay, तो इसका modulus ये expression आ गया. To the power of x is equal to 2 to the power of x. Okay, now this is coming as simplified root 2, and root 2 means 2 to the power of half. So the total power is actually becoming x to the 2 to the power of x by 2, and we had 2 to the power of x here. Now if the bases are same, we can compare the powers, equating the powers. X by 2 is equal to x, cross multiplying x is equal to 2x, taking x to the other side, 2x minus x, which is only x, and here you will be left with 0. Okay, so simple enough. 19th also, children, it's quite simple. Okay, so we had this expression given to us, that product of these four complex numbers is suppose capital A plus IB, then there was this result that you had to prove. Okay, तो by now I think strike कर जाना चाहिए कि ये कोई complex number है, इसका अगर इसके conjugate से multiplication होता है तो ऐसा expression मिलता है, real part square plus imaginary part square. So keeping that in mind, again what we are doing is we are considering the modulus of the complex numbers. So if two complex numbers are equal, naturally their modulus will also be same. Okay, so that is what we are doing. If this is given, the modulus of this side should be equal to modulus of this side, right? Again, property modulus ki product, if you have modulus of z1 into z2, that's modulus of z1 into modulus of z2. So all those properties are being made use of here. So it will be modulus of this into modulus of this, ये modulus sign सब में carry हो जाएगा. Okay, and then we know for any complex number its modulus is under root of real part square plus imaginary part square. तो वो सब में लग गया, तो ये एक्सप्रेशन आ गया. इसको स्क्वायर कर दोगे तो आपका प्रूफ आ गया. तो वेरी सिंपल ऑल दीज क्वेश्चंस आर. ओके, नाउ फॉर द 20th वन इट वाज सेड दिस इक्वेशन वाज गिवन टू यू and they were asking you what will be the least value of m for which this equation will hold true. Okay, तो आप इसको simplify करोगे. Again, what else? You'll multiply by conjugate of what you have in denominator. If you're doing that, denominator becomes real part square plus imaginary part square, coming out to be 2. ये आपका होल स्क्वायर से ओपन हो जाएगा, या मल्टीप्लाई करो विच एवर वे. सो 1 स्क्वायर प्लस आई स्क्वायर प्लस 2i, 0 minus 1 आ गया. So your 2i upon 2. So you end up actually getting only I left. So I to the power of m हो गया, which is equal to 1. So we are familiar with powers of iota. So I होता है, then I square minus 1 होता है, I cube minus I होता है, I to the power of 4 1 होता है. Okay, so we know it clearly that the first time you get I to any power as 1 will be when m, the power of I is 4. Therefore, the least positive integral value of m out here has to be 4. Isn't it?